So we have been talking about fractions and division. So we went over already dividing whole numbers by fractions and dividing mixed numbers by fractions. And now we're going to talk about dividing fractions by fractions. And we are going to use models to do this, right? Because this is really all about models on our performance task. So we have 2/3 divided by 1/2. Okay, so the first thing I want to do is I want to draw my models. And I'm going to draw a model to represent one of my fractions. It's a little different when you're working with fraction divided by a fraction, right? Because there's some tricks you could use. And my second model. And we're going to use those tricks the best we can, right? So I have 2/3 divided by, I'm going to split this in halves because my denominator is 2 and I know that I have halves. Now I'm going to color in to match my fractions. So I'm coloring in 2/3, right? And I'm coloring in 1/2. Now, to find out how many of these halves, right, how many, this is a half, I want to know how many halves fit in to 2/3, okay? So how many groups of halves I can make out of my 2/3. So what I'm going to do, because it's very hard to see, I mean, I might be able to mark it off, but I want to be a little precise. So what I'm actually going to do is I'm going to use the LCM of 2 and 3, or 3 and 2, however you want to say it, right? And the LCM of 3 and 2 is 6. So I want to actually turn my boxes now into sixths, right? And I'm going to do that. I have thirds, so I'm just going to divide it into 2, because 2 times 3 is 6. And I'm going to turn my halves into 6 by making them thirds, right? And actually, I didn't use this box. I'm going to cross it out because I'm not using it, right? So I'm only using these two boxes, and I'm using 1 and 2, right? So now I have 6, and that's actually going to give me a common denominator because the models are equal now, right? So I could actually, right, just count 1, 2, 3, 4 on the top, and that's going to give me my numerator, right? And on the bottom, I count 1, 2, 3, and this is going to give me my denominator. Now, mathematically, right, so our answer should be 4/3, and 3 goes into 4 one time, 1 left over, and 1/3, right, is left over. So mathematically, some of you might know, once I split both models into sixes, their denominators become 6. And we have 4 out of 6 divided by 3 out of 6. Now, if we keep, change, flip, right, our 6's cancel out. Our 6's cancel out because 6 divided by 6 is 1. So they turn into 1s. They have a common factor of 6, of course, right? So now we have, I just want to make some space here. Now we have 4, oh, sorry, this should have been a 3. Now we have 4 over 3. Easy peasy. I know some of you guys saw that right away, so it should have been a 3. Okay, let's try another one. And I'm just going to do that. And we're going to try 5, 6. 5 over 6 divided by 1/3. So I make my boxes. And I make, this is 6. 1, 2, 3, 4, 5, 6. And I make my thirds. And I make my models about the same length, so they're kind of easy to see when I'm dividing them. Okay, now I'm going to shade in my 5, 6. I'm going to cross this out because I'm not using it. And I'm going to shade in my 1/3. And I want to know how many 1/3 fit into 5, 6. Okay, so I'm going to use the LCM of 6, of 6. I use my denominators with my LCM of 6 and 3. And that is 6. Okay, so I want to make my models into 6s. I already have this in 6s, so I don't have to do anything here. For my thirds, I know 3 times 2 is 6, so I turn each one in, I split it down to make them at 2 each. So I have 1, 2, 3, 4, 5, 6. Okay, awesome. Awesome. So now all I have to do, right, is count for my numerator. 1, 2, 3, 4, 5. This is my numerator. 1, 2, and my denominator is 2. So it's 5 over 2. And we can check that, right, using the algorithm. But first, 5 over 2 equals, 2 goes into 5 2 times, 1 left over, and a 2 underneath because I keep my denominator. So we can check that, but first I want to show you they'll each have a denominator of 6, 5, 2, keep, flip, change, cancels out, and you have 5 over 2. Now some of you may not know the canceling out, and some of you do, right? And that's awesome. You really should try to get used to it, but if you don't see it and you struggle with it, you can always do the model method to see it, right? Use the method we use where we use the LCM and we turn each models to have an equivalent amount of boxes, right? And then count. So we have 5, 6, so keep, change, flip, and we have 15 over 6. And again, this could have also been canceled out. But just to go the long route, if you're not sure how to cancel out, right? 15 divided by 6 is 2, right? And that's 12. And then we have 3 over 6, which is 2 and 1/2, right? Because 3 over 6 is 3 is half of 6. Okay. Let me see if I can move that to show you. Move it out of the way. Yeah, it's fine up there. Okay, let's try another one. And there is even another way you can do this. Let's try to do it similar to what we've been doing in our other lessons where we did our whole numbers and fractions. Right, and I could leave the information up there. I'm not right? So we had 5, 6. Some of you might know how to do it this way, and that's okay. So you see, I'm going to cross this out, we're not using it. We want to find out how many 1/3 fits in 5, 6. So we see that 1/3 fits in 5, 6. And we see we have another 1/3 that fits in 5, 6. And now over here, right, we need to find out what this equals. And I actually noticed that each of my 1/3s have 2 of the 6s. So if each group is 2, I have 1/2. And that gives me 2 1/2.